All right, so last week really on solving systems of equations. So remember, first week we talked about how to use graphing and substitution, and we just reviewed it. Second week we did all the stuff with elimination. We had all the cases you had. Third week we did, that was all word problems. Every problem was a word problem. A couple word problems this week, but it's not the whole week. And now the fourth week we're looking at kind of special things that can happen. We've been used to always getting one solution for X, one solution for Y. Well, sometimes that doesn't happen. Sometimes you get a no solution, meaning whoever made up the problem, it's not solvable. And it's not that it means you get a decimal, it means that you can't solve the problem. Like, there is no answer to it. And then the opposite of that is when you have a problem that has a ton of answers, right? And we already talked about that phrase. What's that phrase we use when you have an infinite amount, blank, blank, blank? All real numbers. So we're going to see those two things come up. All right, so on your guided notes, you got a blank right at the top that says solution of systems of linear equations. And this tells you the three things I just said. So what's underlined? You want to put that down. A system of linear equations. Remember, linear means lines, like straight lines. There's three things that can happen when you draw them. You get one solution. Okay? What does one solution look like when you draw it? Looks just like somebody said earlier. The two lines cross in exactly one spot.
You guys, above, you have those graphs in the middle of the page. Above each graph, you'll write one solution, no solution, infinitely many. You won't have to draw the graphs, they're already on there, but you want to write above each one what it is.
Now, the no solution, I asked you guys, like if you draw two lines and they don't cross, what do we call that from geometry? Does anyone remember what that was called? Parallel, right? So when you have no solution, right? The solution is where the lines cross. If you've got two lines that don't cross, they're parallel. There's no solution. And then Gigi, you told us the last one earlier. When you have infinitely many solutions, it means that the two lines are what? They're right on top of each other. So that one's hard to see, but pretend like you have two lines right on top of each other. And you say, where do the lines cross? Well, if they're right on top of each other, they cross everywhere. And that's all real numbers. Okay, so that's the three things that can happen. For the past 3 weeks, we've been right here. One solution. That's all we've done. So most of the problems this week are going to focus on the no solution and infinitely many. It doesn't mean we couldn't give you one that has a one solution. We did in the warm-up. We gave you one that just had one solution. But most of the stuff we focus on, bless you,
Thank you.
it's going to be the no solution and infinite solutions. Okay, so make sure on your guided notes you copy down what was underlined, and then on the graphs too, you've got that stuff to fill out. One solution, no solution, infinite solutions.
And then on the bottom, you have space to the right just to describe what it is. The lines intersect, the lines are parallel, the lines are the same. You can write that below each graph.
Yep, everything that's underlined. Okay, everybody good with copying that stuff down? You good? Okay. So, what method to use? We talked about two methods in the warm-up. We did graphing, we did substitution. Sometimes one method is better than the other. Depends on how the problem is set up. Okay, if I just look in the notes, like if I was doing a problem like that, it's already in y equals mx plus b. I'd say that's pretty good to graph. Okay. Problem like that, I don't know. It's not in y equals mx plus b, so maybe I would try something, maybe I would get it in y equals mx plus b. Maybe I could use substitution. Actually, in a problem like this, I would use elimination. Because all you got to do is double one of these, and then you get the other one. Well, not double, quadruple. But, all right, so lots of different ways you could solve it. So if you're looking at a pattern like this, the y isn't by itself, right? If you've got like x plus or minus y equals a number. That's kind of like in the third one I just showed you. X plus or minus y equals a number. It's not really set up for graphing. So the option there, we'll probably stick with showing you guys the same way to do it. So we can stick with elimination. You could do substitution, but we'll probably just pick one way and show you that one way. But if you do it a different way on the test, like you say, you know what, I'm going to use substitution, and you do it right, yeah, it's fine.
Like on the test guide, I wouldn't use like if you say like it said like the directions on that last one that say like it says like, it doesn't tell you what to do. It doesn't say solve by substitution. It doesn't say solve by graphing. But if there's no graph, then obviously you can't do graphing. You have to do substitution or elimination.
Yeah, so you'd have a choice. Now, if it's a problem that it says specifically solve by graphing and there's a graph there and you decide to do substitution, no, the problem was to solve by graphing, so you didn't do it the way you're supposed to. Now, when it's in the y equals mx plus b, all right, that's when we get the slope and the y-intercept set up. Perfect, ready for graphing. Or, if you're not given a graph, like Mr. Roy said, substitution is also perfect for that one because y equals mx plus b, you already have a letter by itself. Y is already alone. So when it's in y equals mx plus b, you kind of go either way with it. If you're given a graph, graph it. If you're not given a graph, use substitution. If there were no directions, could you use elimination? It's up to you. I mean, I would probably go with one of the two methods we're saying here, but if there's no directions, you can solve it any way you want. But I think some ways are going to be easier than others. So if you do a problem with elimination, we're not going to go through all 5 cases all over again. Like, you know, do you have this, do you have that? You remember the goal with elimination. You've got a number in one equation, a number in the other. You've got to get them to be opposites. Like a plus 5 minus 5, plus 6 minus 6. That's the goal. Okay, get the numbers to be opposites so they cancel. Okay, we don't care if, you know, if you can go through the cases in your head, that's how you want to think about it, that's good, you should. But if you're stuck, and you're like, I don't remember case 3, that's okay. Just, we'll go through it. I think that's it. Yeah. Okay, so everybody have 2 suggestions for what, you know, that's what we suggest you try for this, which method to use.
Can you repeat that?
These are just the two types of setups that we're suggesting. All right, if you see like 3x plus 2y equals a number, our suggestion is to use elimination on that.
Okay.
If there are no directions, you want to use substitution, go ahead. But we're saying elimination is probably going to be easier. All right. This one you don't really have a choice. It says solve by graphing. There's a graph set up. So if you did substitution, you ignored the directions. So you've got to solve this one by graphing. All right, now one thing that can be kind of a pain about graphing is you can go off the graph, which looks like that's probably going to happen here. All right, look at this equation. You've got a y-intercept of 12, and you're only going up from there with the slope. So already we're starting off the graph, and we got to go even higher. So we probably don't want to go by ones. It's not going to work. What do you think we should do?
We could go by 3s.
We could go by 3s? I would say 3s is perfect because look at it. That's a multiple of 3, 3, 3, 3. Every number is a multiple of 3. All right? So let's go by 3s on everything. Okay, so I'm going to make this 3, 6, 9, 12, 15, 18. All right, I don't have to number all of it, just Number enough of it. 3, 6, 9, 12, 15, 18, 21, 24, and so on. Okay, so we're going by threes. First thing I want to do here is turn that slope into a fraction. Ellie?
What do you do? 3 over 3, 3 over, or 12 over 3?
We don't want
3
to.
over negative 3?
There's only one number you can put in the bottom that won't change the fraction.
1.
1. Yes.
Here's the bottom column.
Yeah. 1.
And then 12 over 1?
You can put the 12 over 1, but we don't need that one as a fraction. The only one we need as a fraction is the slope. Okay. So now, what's my y-intercept in the first equation?
12.
12. So what am I going to do? How am I going to show that on the graph?
Go up 12 and over.
You're gonna put a dot.
We're going to put a dot at 12. Now, yes, I know that it's only up 4 grid lines. But remember, each grid line is 3 units. So the dot is at 12. Okay. Now, the slope from here tells me to go up how many and right how many?
Up 3, down 1.
Up 3, over 1. Now, over 1 is a little tricky because our graph goes by threes. So you could go up 3, right 1. What's another way to write the fraction 3 over 1? Can anybody write it with bigger numbers?
1 over 3.
Think of like the reverse of reducing it. Give me a bigger version of the fraction 3 over 1. I like that. 9 over 3. Isn't 9 divided by 3 the same as 3 divided by 1?
Yes.
Same thing. That to me is easier to think about. Why? Because my graph goes by threes. Right? To go up 3 and right 1, don't go like this. You'd go up 3, 1, 2, that's up 3 right there. Right? Because we went by threes. And then right 1 is like a third of the block because it goes by threes. It's easier to think of it this way. Up 9, right 3. So up 9, 3, 6, 9, right 3. What I just did there is up 9, right 3. I went from 12 to 21. That's up 9. I went from 0 to 3. That's right 3. Any question on that? Now I'm going to do it one more time because I think I can fit it on the graph. I'm going to go up 9 and right 3. 3, 6, 9, right 3. You ran out of space?
Yes, sir.
You didn't? Okay. Now, let's draw our line the best that we can. I think it's going to look about like that. Yeah, that's perfect. That's exactly what you want. Okay, the way I was drawing it is I was actually looking ahead to see, okay, what if I went down and then left and then down and then left and then down and then left. I was trying to make sure it lined up if I had put more dots in. Okay. On your paper, it's easier because it's smaller, so you can do it. On the board in the front of the room, it's huge, so it's hard for me to sometimes line it up. Because if I'm off just a little, graphing doesn't come out good.
Why don't you just use the graphing calculator?
Because I'm trying to do it the way you guys are going to have to do it. I mean, I could graph that super fast on the calculator, but you guys aren't using those for this stuff. Yeah. All right, let's do the same thing here. What's the y-intercept of the second equation? 6. Okay, I'll do this one in a different color. Put a dot at 6. All right. Now, what's the slope? Yeah.
Could it be like 3 over 6?
All right. Which way does this tell me?
Negative.
Which is
Down.
down.
So would it be like negative 6?
What about the bottom now?
Oh, 1. It's probably 1.
So it tells me
So
to go,
like down 3 over 1,
which way's over?
right?
Yes.
You
Now,
don't have to make it bigger.
I would try to think of that bigger because if you go right 1, that's like a third of a block.
So how would we do that?
So think of a bigger version of that fraction. It's
3
like
over 1?
yep. It's like the opposite of reducing it. Negative 9 over 3, that's negative 3. Negative 3 over 1, negative 3. It's just a bigger version of the same fraction. All Nicole did was really multiply the top and bottom by 3. Now that's easy to do. Let's do that. Down 9, right 3. So down 9. 3, 6, 9. Okay, right 3.
Oh, my numbers are getting in the way.
Well, yeah, I had another dot in the way too. Down 3, 1, 2, 3. That's down 9, right 3. Let's do it again. Down 9, 3, 6, 9, right 3. 3, 6, 9, right 3. And I got an extra. Okay, so let's
Oh, yeah.
put a line in there and see what we got. This one's really testing my graphing skills here.
Wasn't that always a good thing?
It's a little gap.
Those lines are pretty good.
Oh, yeah.
They're beautiful.
Yeah, they're pretty much where we want them. Because if I went up 9, 3, 6, 9, right 1, yep, 3, 6, 9, right 1. Okay, so now the question is to figure out where they cross. Let's zoom in. This is a tough first problem. Let's assume that we get a nice answer. Okay? Let's start with the y value. I think the y values cross at a nice spot. Where do the y values cross? At what number if you go up? I think they cross at 9. Right? To me, it does look like they cross at 9.
Are you sure?
No. I'll check my answer and hopefully it works. So
I hope also.
I think the y values cross at 9. All right? I'm trying to remember, we said we usually give you problems that work out nice. Now,
Today, because today's not a good.
what about the x value? It looks like it's a little bit to the left. I think it's negative 1.
I agree.
All right? I think it's,
Oh, yeah.
remember, if this is negative 3, is it halfway? No, I don't think it's quite half. It's just a little bit. So if we're going to assume it's a nice answer, I think it's negative 1/9. Let's try it.
I know it works for that first one, Mr. Hager, when I looked at it.
If you plug in negative 1 for x, you get negative 3 plus 12.
This is the first one, right?
That's 9.
Works for the first one.
Works for the first one.
Check the second one.
Let's check the second one. If you plug in negative 1, what's negative 3 times negative 1?
3.
3. What's 3 plus 6?
Oh, my God. It's
Huh?
over.
Well done, Mr. Hager.
It's over.
Now,
It's
that,
over.
that one was a little tough because we had to go by 3s and we had to kind of look at it close. So that's an example of like one of the hardest kind of graphing
Yeah, I
problems.
think, guys,
we have.
we'll make sure, we'll make sure on the test, guys, the graph, it'll go by 1. We just had to do it like that for this one, but we'll make sure on the test, the graph will go by 1s.
Do you guys see why I had to go by 3s? Because my y-intercept was at 12. I would have already been on the graph, and then I would have had to go up 3 from there. I would have been at 15. I would have been way off.
You've been flying.
All right? I would have been flying off. All right? So tough one with graphing, but if you followed that one, you did really good job. Any questions on that one? So that's why we don't like graphing. It's not that it doesn't work. We just did it. It did work. But I had to be super careful. I had to draw things. I had to zoom in and look at it. That's annoying. All right? So we're going to go through less annoying ways with substitution.
Yay!
All right, so like Mr. Hager talked about in the beginning, right?
Yeah.
We could graph this. It's in y equals mx plus b. We could graph it, but the directions are telling us to use substitution. All right? So we have to, again, there's no graph here. We'd have to draw a graph, do all the grid lines, do this be, and it's not telling us to do that.
And it'd be a pain in the butt.
It'd be a pain in the butt, yes. All right, so substitution, like we talked about, if I go back, we told you what methods to use. When y is by itself, we could use graphing if it gave us the graph, or we could use substitution. This one's telling us to use substitution. All right? So when I substitute, what am I going to plug in? What information am I going to plug in for what letter? Yusuf?
I mean, since like Mr. Hager said, like if there's like they both have like the y variable by itself.
Yeah.
Get the 2x minus 3 from the top and plug it in for.
Yeah. I'm going to put a circle around that, and I'm going to draw an arrow. So in the bottom, all right, y is going to become 2x minus 3.
Oh yeah.
Because y is by itself up here, so I'm just going to plug it in down there. So can someone tell me by raising their hand, what's my equation going to be once I plug in that information? Ellie?
2x minus 3 equals negative 2x minus 7.
Yep. 2x minus 3 equals negative 2x minus 7.
Hi, I'll borrow your keys again.
So all I did was just plug that in.
Is this meant to fool?
Alright, so now, alright, Bethany, what am I gonna do now? I'll give you a hint. We're gonna move some stuff. It doesn't matter what you move first. You have two options. You can either move the numbers that have no letters attached, or you can move the numbers that have letters attached. It's up to you. So what do you want to move first? The numbers, okay. Which number? So what are my two numbers with no variables, Bethany? Yep, careful, right? Negative 3 and negative 7. Which one do you want to move? It doesn't matter. Okay, I'm going to move you said negative 3? So what do I do? So it's negative here, so what do I have to do? I don't want to subtract because it's already negative. Add it. Guys, you can look at your test after. Pay attention to this.
My bad.
My bad, Mr.
Alright, this eliminates, right? So I'm left with 2x on this side equals negative 2x, negative 7, positive 3. It's going to be negative 4.
So negative 2x minus negative.
So now, what am I going to do next? I'll give you a hint. I don't want to move this. I just moved the 3 to this side to get negative 4. So I don't want to touch that negative 4. That's not going to move. Ellie?
Would you move 2x? Like, would you subtract?
Am I going to move the 2x or am I going to move the negative 2x?
Negative 2x.
Alright, so how am I going to move it?
Subtract plus 2 from
Plus 2x. I'm going to plus 2x here. I'm going to plus 2x over here. I'm going to get 4x equals negative 4. Alright? One more step. Divide by what? X equals negative 1. Alright? How do I get y? How am I going to get y now? Gigi? Which equation do you want to use? I could use either one because y is by itself in both, so it doesn't matter what I plug it into. But Gigi said she wants to plug into the top one. That's fine. Can somebody tell me what that? So it's going to start with y equals. What's the rest of the information going to be after that with the negative 1 plugged in? Can someone tell me? 2 parentheses negative 1 minus 3. Again, all I did was I took the negative 1 that I just solved for x. I plugged it into the top equation. I could have plugged it into the bottom equation too. It doesn't matter. I could do either or. But if y was by itself in only one of those equations, I would choose the equation that is y by itself. I wouldn't do the other one, right? Because all I got to do now is just do the arithmetic on the right-hand side. 2 times negative 1, negative 2, minus 3. They're both negative, right? It doesn't become a positive. I keep the sign, and I add the numbers, What number is it going to be?
-5.
-5.
Got this one.
So my answer is oops. It would be -1, comma, -5. So if I did this, if I use graphing for this, all right, I'd have my graph, and they would intersect at -1, comma, -5. That's where it would intersect. All right. I could have solved. I mean, if this told me to solve, this said solve the system, I could have done graphing, or I could have done substitution. But again, I think substitution's a little bit quicker, and then you'll know. You don't have to guess where you don't have to like look and see where that coordinate is. You'll just know. -1, comma, -5. But if I did graph it, my graphs would intersect at -1, comma, -5. All right?
I'll do better.
Good? Everybody has this? Yes?
No.
Everybody's good?
Yes.
Yusuf, you have this?
Yes.
This one. I want to change this. We're not going to use that. We're not going to use that one. We're going to go 15x minus 5y. All right. So this one that says solve the system of linear equations, check your solution. So I'll give you guys a second to write that down. You already have the directions. We're not going to use it. I don't want to use this example. I want to use this one.
Hold on, what?
So the one I crossed out, obviously don't use that one. Stay as
Is it because it's easier?
You'll see in a second why I wanted to change it.
Because it's an April Fool's.
No, it's not April Fool's. I know it's April 1st. It's April Fool's. You know.
I'm gonna be careful.
You've definitely hit the nail right on the head with that one today. It's April Fool's. We know. All right. So this one, it's not set up like the last two we've done, right?
No, sir.
So what am I gonna? For me, obviously I'm not gonna use graphing because there's no graph. What's another option I could use that I probably wouldn't want to use it here. What's another option?
Elimination.
For this one I would use elimination just based on how it's set up, because we said x plus or minus y equals number. I have that in both equations, so I would use elimination.
Yes, sir.
So when we solve using elimination, what are we trying to get? What two things do we want to be the same? Same blank, different blank.
Oh.
Good, Nicole. Same letter, same number, different sign. So I want to look and see. No, I got a 15 here, I got a -3 there. Those aren't the same. I got a -5 here, I got a y there. I got a 1. Not the same. So it's not set up to eliminate. You're gonna have to do some type of
Change.
Okay, so to be able to change this, right, we're going to have to use some type of math operation to change it to get what we want. What operation is it going to be? To get what I want, when I do elimination, to get one of the equations to eliminate. Sometimes, very rarely, when we did it a couple weeks ago, very rarely did you have to do this in both equations.
I know.
You had to do it in one. Ellie?
X plus.
Yeah, I know. That's the order we wanted in. But what am I going to do? What do I have to do to get it to eliminate? What operation? Yes, Nicole. Good. I'm going to have to multiply. So maybe I didn't hear you. I'm sorry. Whoever said it. So it's not set up to. So I'm going to have to multiply because it's not set up. It's not same number, same letter, different sign. I don't have that. We said so. Like Mr. Hager said, you don't have to remember all the cases, but if we have a single variable in one of the equations, that would be the equation we want to multiply. So do we have a single variable in one of the equations?
Yes.
Which equation has it? The top or the bottom? Brady, which variable is by itself? Nothing attached to it. In the bottom.
The y.
The y. So I'm going to put parentheses around the whole thing. because we know we're going to have to multiply this bottom equation by something, because it has the single variable. Does anybody know what we're going to multiply this bottom equation by? What number? Elliot?
-3.
Not -3. What do you think? Okay, so if I multiply the bottom equation by 3, I'm going to end up getting, -9x plus 3y equals 12. So, will anything eliminate? No. Again, the y is by itself, right? What's attached to y in the other equation? Donovan? -5. So what do I want, Donovan, what do I want to multiply this bottom equation by? To get it to cancel out. If I did it by -5, I'd still end up getting -5y on the top, -5y on the bottom. I want them to be opposite. So what would I multiply the bottom by? It's 5. If I multiply it by a part, so I already get the opposite signs. Okay. Here's my 5. All right, so I'm going to multiply. If I multiply it by a positive, then it'll eliminate. So I'm not doing. All I'm going to do is take the top equation and rewrite it. Because we don't have the template that we used when we did elimination. So I'm just going to rewrite it. When I multiplied the bottom equation by 5, what am I going to get? 5 times -3x is what? -15x. 5 times y. Positive 5y. 5 times 4? 20.
I know we can.
We know that when we multiply by 5, the y's are going to eliminate. Those are going to cancel out.
Say goodbye.
All right? Say goodbye to those. Now, I want to do the arithmetic, the subtraction or addition that's left vertically.
But they all go out.
Exactly. 15x minus 15, 0.
And then 20 minus
-20, positive 20,
0.
0. Is that true? Is that a true statement?
Yeah.
0 is, because remember we said equals means, we did word problems last week, is.
Yes.
0 is 0.
Yes.
That's a true statement. How many solutions am I going to have?
0.
No.
1.
No.
Infinite.
Infinitely many. So the answer to this will be, it has infinitely
Which basically equals 0.
many or all real numbers. Meaning I could plug in any combination of numbers for x and y, as long as they're whole numbers. -1, +5, -20, 32. I can plug in any numbers I want for x and y, and my answer will come out.
Do people understand the difference between the two things Mr. Roy wrote there? One thing he wrote is how many solutions there are, and then he also answered what they are. How many are there? Infinite. What are they? All of them. All real numbers. So he answered 2 questions.
So if we gave you like a multiple choice question on the test, and you did all the work, and then asked for like how many, we might say, you know, solve the system, determine how many solutions. It would be infinitely many. That's why I wanted to change this one, guys, so you could see one that had infinitely many solutions. And you may not get 0 equals 0. If you may do the work and end up getting like -5 equals -5. So when, like in this case, the variables, the x and the y, they both canceled out. Or if you're doing one where maybe the y you have no variable left, and you have just numbers, like this. If the numbers match on either side, you have infinitely many solutions. As long as the numbers match up. If I had 0, 3, is that true? Is that a true statement? 0 is 3? No. If I had something like that, no solution.
Did we have 2 of the same type? Is that why you have to change one?
Yeah, I want to change it. I can see one
The next one is different.
with no solution.
Yeah.
We can do one. I'll change one of the practice ones, and they can do another one, another type. All right. So if the numbers don't match up, then you have no solution. So if I if I rearrange this, if I was to rearrange both of these equations, all right, if I put them in like y equals mx plus b, I get the same exact line, all right? Like, what was my original? I had 15, sorry, mistaken. I had 15x, right? 15x minus 5y equals negative 20. And I had negative 3x plus y equals 4. So if I wanted to put this in like slope-intercept, what I would do is I'd have to minus 15, so I'd have negative 5y. You don't have to write this down. Equals negative 15x minus 20. I divide by negative 5. I get y equals 3x plus 4. So this bottom one, when I simplify that, I should get the same thing. Add 3x, y equals 3x plus 4. So if I wanted to put it in slope-intercept form to graph it, look at the line. Y equals 3x plus 4, y equals 3x plus 4. It's the exact same line. So like what we talked about in the beginning when we showed you the different ways it would look when you graph it, these would be the exact same line. That's why it's infinitely many, because they land right on top of each other. It's the exact same line. Does that make sense?
Yeah.
All right. But again, for this, I'm just showing you how it would work out. Why it would be infinitely many if I tried a different method, graphing or substitution. All right? But here, when it's set up like this, I would use elimination. All right, one more. Skip that. Come back to that. Let's do this one. 2x plus 3y. You guys can just put this on your notes from extra example B. Extra example A, rather. Equals
Unless you wanted to get yourself.
4, and then 6x plus 9y equals negative 12. So we're going to call this example 4. Yes, we'll just change, we'll just get rid of it, extra example A, and we'll just call this example 4. So for this one, Nathan, what method do you think we might want to use? There's three methods, right? Out of those three, which one do you think we want to use? We could use substitution, but that's going to involve me getting y, either x or y by itself. So I'm going to have to move some stuff around to be able to do that. You're not wrong, but you might make a little bit more work for yourself. All right? What do you think, Mary? Elimination. I would use elimination. Again, if this says solve the system, fine. Do whatever method you want. Me personally, I would use elimination. Donovan?
Would you multiply the top equation by -3?
I would. Yeah. Donovan got a little ahead, but that's fine.
Yeah.
I'm going to multiply by -3. Reason being, I don't have same number, same letter, different sign. It's not already set up to eliminate right off the bat. I don't have that. All right? I don't have a single variable in either equation. I don't have an x with no number attached. I don't have a y with a number not attached to it. Okay? Donovan thought to himself, okay, can the smaller number go into the bigger number? Yep. If I multiply this by -3, I'll get -6. I'll get -6. Right? So the x's will eliminate. Or you'll see that in this case the y's are going to eliminate as well. It doesn't always work out that way, but -3 times 2x, -6x. -3, so I'm going to distribute. Make sure I do it to all three terms. -3 times +3y, -9y. Negative 3 times a positive 4, negative 12. Remember, when we multiply, we have to multiply to all three terms, even a number after the equal sign. I did nothing to this bottom equation, so I'm just going to take it and rewrite it.
And you get no solution because they're all.
Let's see, hold on.
Interesting.
The x's cancel out, right? The y's cancel out, right? Negative 9, positive 9, they cancel out. What's left on this side?
Negative 24.
Negative 24 on the right. How about the left? 0.
Oh, so there's no solution.
This would be no solution. It's not no solution. When it's not a true statement, 0 is negative 24. No. What number would have to be on the left-hand side to make this infinitely many solutions?
0.
On the left.
Or 24.
Negative 24 would have to be on the left, or 0 would have to be on the right. That's the only way it would work, is to be infinitely many. No solution. All right. If I was to rearrange this and put it in slope-intercept form, so 2x plus 3y equals 4. I want to get y by itself. You don't have to write this. Minus 2x, minus 2x. 3y equals negative 2x plus 4. Divide by 3, divide by 3, divide by 3. Y equals negative 2/3 x plus 4/3. All right? If I wanted to do that first one in slope-intercept, that's what it would look like. All right? Let's look at the bottom one. We had 6x plus 9y equals negative 12. We're going to minus 6x, 9y equals negative 6x minus 12. Divide by 9, divide by 9, divide by 9. Go. Y equals, this will reduce to negative 2/3x. This will reduce to negative 4/3. Look at the slopes.
That's crazy.
Are they the same?
Yeah.
So if the slopes are the same, that means the lines are going to be what?
On top of each other.
No.
Or over each other?
Are they-
No. They
They'll be,
Well, if the slopes are the same, they could be on
Yes.
top of each other.
Donovan's right.
That's what I said.
Parallel, right? They're never going to touch. So same slope, different y-intercept. That means that we're going to have parallel lines, and they're never going to intersect. That's why it's no solution. So again, on the test, we're not going to make you like, okay, you know it's no solution, like prove it graphically. We're not going to make you do that. I'm just showing you that if we were to use graphing, it would work out. It would be no solution if I graphed this because the lines are parallel and they would never intersect. So that's why we wanted to give you, in the notes we took today, we did 2 examples where you have 1 solution. We did 1 example where you have no solution, and 1 example where you had infinitely many. So you have 1 of each now, at least 1 of each. And chances are, you'll probably see 1 of each on the test on Friday. You'll see a no solution, you'll see one with 1 solution, you'll see one with infinitely many. And we'll probably make you do one with graphing, we'll make you do 1 with elimination, and we'll make you do 1 with substitution. We'll make you do all 3 types. Right? And we'll tell you, solve by substitution, solve by elimination, solve by graph. You'll know. All right? We go back. So, homework tonight, I think there's 4 examples, 4 questions you have to do. Remember, it's the last week of 3rd quarter. Grades close on Friday. Test on Friday, I know it says last of the quarter, that's wrong. Mr. Hager's going to change that. Remember, the homework this week will still count for 3rd quarter, but the test on Friday will count as the first of 4th quarter. Remember, guys, both of us, Mr. Hager and I, will be out to school on Thursday. A reminder for some of you people out there that summer school is a real thing. If you don't pass, the grade comes up to a 58 or a 59 for the year. Unfortunately, you'll be here during the summer. Avoid it now. Put the work in now so you don't have to be here over the summer. All right? I'm not here Wednesday. Mr. Hager's not here Wednesday. There's no after school on Wednesday because of the superintendent's dinner. No one's staying after on Thursday. They want people out of the building Wednesday. No after school on Wednesday because they want to clear the building out so they can get all set for superintendent's dinner. So even if you're thinking about hanging around after school, don't be here. The school will be on like red alert. They want it to go well on Wednesday night. It's the biggest fundraiser for the school. And when you guys become seniors, like you want scholarships, that's where a lot of that money comes from, the superintendent's dinner. All right? Cool. I'll give you the homework.